Hello students, this is the second lecture of friction. In previous lecture, I discussed about the static friction. Now, today I will discuss about kinetic friction. Now, let us consider a block which is resting or sliding over a stationary surface. Now, for impending motion means the motion is about to start. The body is just about to start the movement, that is called impending motion. So at the time of impending motion, the free body diagram of the body will be, if we are applying force P in this direction, and the second component will be the weight, that is equal to mg. The reaction opposite to weight, that is R, and the friction force opposite to P, that is F. So for just about to move condition, we will take this as P dash and F dash. So this condition is for the impending motion when the body is just about to move. Now if we are considering the surface is a rough surface, and we are considering one more reaction R1, and again we are assuming the angle of this reaction R1 with the vertical component R is phi. Here we are considering, because of the rough surface, there is a reaction in unknown direction, and we are assuming this angle between R1 and R, that is phi. So if we find out the component of R1, the vertical component and the horizontal component, so it will be R1 cos phi, that is equal to R, and R1 sin phi, that is equal to F dash. Now if we take tan phi, that is F dash by R. So from previous equation we can say this F dash is equal to mu R, and we are considering the condition is static or just for impending motion. So this mu we are considering as mu s, and that is divided by R. So here we will have the equation, that is tan phi equal to mu s. So if we have the angle phi, or if we have the value of coefficient of static friction, this mu s is the coefficient of static friction. So we can say, if we have the value of mu s, we can easily find out the value of phi. So if we know the angle phi, so we can find out the direction of this reaction R for impending motion condition. This condition is for impending motion. So if we find out phi, so with the help of phi we can find out the direction of reaction R1. Similarly, if the body is in moving condition, when the body is in moving condition, so the diagram will be, the body is in moving condition, so it is P dash, and the friction force we are considering as F double dash. The weight is same, W equal to mg, and one more reaction R opposite to W, and we are considering here R, reaction R1 with angle phi 1. The angle is phi 1. So here we can find out the value of phi with equation tan phi equal to mu k. So this is the equation for when the body is in moving condition. Now this is we can find out the value of phi by coefficient of kinetic friction. Here we can find out the value of phi by coefficient of static friction. Here if we know the value of mu k, coefficient of kinetic friction, we can easily find out the value of phi. Or if we have the value of phi here, we can easily find out the value of mu k. Here we can assume this, or we can denote this angle if the condition is static. So we can denote as phi s, and here the condition is kinetic. So we will write here as mu k. One thing you should remember about the direction of friction force. If I am considering two blocks, both are in moving condition. This is block 1 and this is block 2. The velocity of block 1 is v1. The block 1 is moving with velocity v1 and block 2 is moving with velocity v2. So how can we find out the direction of friction force for block 1? So if we draw the FBD for block 1, so according to free body diagram, the direction of motion of block 1 will be this. So the velocity of block 1 is v1. Now the relative velocity for this block 1 will be v1 minus v2. So if the relative velocity v1 minus v2 is greater than 0, in that condition only the friction force for the block will be in this direction or opposite to the direction of motion. Now if the relative velocity is v1 minus v2 is less than 0, in that condition the direction of friction force will be this. The direction of friction force will be same as the direction of motion of the body. So we can say the friction force depends on the relative velocity. If the relative velocity is greater than 0, in that condition the friction force will be opposite to the direction of motion, and if it is less than 0, the friction force will be in opposite, in this direction only. Now the another case, when the body is moving on the stationary body. This block 1 is moving on the stationary body and the velocity of this block 1 is v1 and it is moving on this stationary body. This is body 2. So the velocity of this second stationary body v2 will be 0. So here if we say the v1 minus v2, so v2 is 0 here, so it is always greater than 0. So we can say the friction force will be in opposite to the direction of motion. So here if we say the friction force always act opposite to the direction of motion, so it is applicable for this condition only. If the condition is this, in that condition this concept will be applicable. Thanks for watching the video and subscribe the channel for more lectures.